G'day everyone, my name's Adrian and I'm the lead author for the geography component of this series, and I'm here today to talk to you about how the series can be used to help students develop geographical skills throughout Year 7 through to Year 10. A really important thing is to expose students to a range of different data types and different analysis skills throughout each year level, and to make sure there's a balance in these skills between hands-on, things like traditional forms of map analysis, but also the use of spatial technology to assist with that. Data and the skills need to be relevant to the topics being studied. This helps students to understand both the skills but also the content. And these skills should increase in complexity as students develop from Year 7 through to Year 10. Also, highly recommend that scaffolding should be included where appropriate to support students who may have some difficulties with some of the skills. And a really important point is not to just teach skills for the sake of teaching skills. This makes geography incredibly boring and unnecessary. So some ideas of some of the skills and data that we've included here in Year 7, for example. This is just a snapshot. We have different types of line graphs that can be used for comparison. In this particular one, it's about water storages in Melbourne. Segmented bar charts, pie graphs, stacked line graphs, which are quite complex, and tables of data where students might have to order the information or calculate averages or percentages. Also a range of different types of maps and other graphs, such as climate graphs, rainfall maps here, elevation data, other sorts of choropleth maps, and satellite images are also quite common, in particular to help students to see changes over time. In Year 8, in the Changing Nations chapter, we have some other types of data. This graph's particularly great, I think, where you've got the urban population and the rural population, and students can see where they meet, and they can see what's happening in the future and continue the projection if they wish, and have a look at what it may look like in 2050 or 2100. And on top of that, we have the world population as well. These sorts of scatter graphs are excellent, and there's links to some websites where students can put in their own variables and have a look at the relationship, for example, between urban population and GDP per capita, and see as the urban population increases, GDP per capita also tends to increase. These sorts of migration maps are excellent as well, so students can see where people are moving from and where they're moving to. This particular one's focusing on internal movements within China, but there's also another map having a look at international migration as well. Some other types of data that Year 8s might see are things like, here we've got a choropleth map of the urban population, and overlaid onto that is the size of cities. So students can see not only which areas have the highest urban population, but also whether that urban population is confined to large cities such as megacities, or just spread more evenly over smaller cities. Cartograms, where students can see areas exaggerated to represent the data that's in a legend. And here we have natural population growth, and we have urban population growth rates. And students can have a look at the spatial association between these maps and see whether or not natural population growth is having a major or a minor impact on urban population growth rate. And another type of mapping skill that we have a look at is the change in distribution over time. So here's the same variable, having a look at it in 1950, 1990 and 2015, and students can track how that's changed, in this case, the proportion of people living in urban areas. Throughout the chapter, we have all that data within the text, and we have these things called developing geographical concepts and skills. So this is where it explains what the skill is, so in this case describing what the spatial association actually means, and then giving some pointers or some scaffolding, in this case showing students how to answer that type of question. So we also have how to describe a spatial distribution, drawing and interpreting line graphs, population pyramids, thematic maps, stacked line graphs, bar graphs, Gapminder, where they can have a look at the association between variables. And that's just a snapshot. Plenty of these sorts of things throughout each of the year levels. Year 10, the data gets a little bit more complex. So here we have an example of the water cycle, but much more detailed than the version Year 7. Here we have a process diagram having a look at mangroves and the impact that has on an environment. Stacked line graphs once again. This particular graph is fantastic. This looks at the temperature range and the precipitation range for different types of environments around the world, relevant to Year 9 biomes, but also Year 10 environmental change and management. And population pyramids, students learn how to analyse these in terms of their overall shape, indentations, bulges, have a look at the aging population, the young population. And in the Year 10 chapter, they apply this to the well-being of Aboriginal and Torres Strait Islander peoples. And this graph's fantastic at comparing quite a stark inequality issue between Indigenous and non-Indigenous Australians. And I'll take this opportunity to say that each of the year levels has at least one case study having a look at Indigenous Australians, whether that be traditional forms of land management or well-being. So students definitely get good coverage over Indigenous issues. In Year 10, students often get the opportunity to have a look at some more complex types of maps as well. Topographic maps are used throughout the series, and here's another example of a unique type of map. In this case, it's the health of different study points, study areas along the Yarra River from the Yarra Reservoir to Melbourne, and students can have a look at how the health of that water quality varies.